Hi everyone, my name is Ricky. I'm a junior software developer at FIL. I'm kind of new to the Web3 space, so bear with me for this presentation. Today I'm going to talk about multi-chain storage and the SDK that I built to use it. So multi-chain storage, also known as MCS, is a blockchain storage solution that provides a data cache and a persistence layer using Filecoin and IPFS. It's a smart contract-based cross-chain storage gateway currently deployed on the Polygon testnet, and the Polygon mainnet deployment is in the works. It's also integrated with Oracle technology. And the data is stored using the IPFS protocol, which is incentivized by Filecoin. And here, MCS will act as a middleman, allowing users to pay in other types of tokens other than FIL. So yeah, users will upload files to MCS, and they can pay in other native tokens or other mainnet tokens. And in the back end, MCS will do the swap into FIL and perform the Filecoin storage. This is in hopes to integrate other blockchains, the interoperability, because currently, without some sort of bridge between blockchains, users will have a hard time experiencing the full potential of blockchain technology. And we hope to bring data storage to the next level of security and decentralization. So how it works is that when a user uploads a file, they have to pay in some sort of token, for example, Matic token. It gets locked into the payment contracts, and the price is estimated based on the average price of all the Filecoin miners on the network, the size of your file, the number of copies you want, and also the duration of the storage. Once your tokens are locked into the contract, it will be swapped using decentralized exchange such as SushiSwap. And we will perform the Filecoin storage using our MCS internal wallet. And once the proof of storage is on chain using the DAO, it will scan the network and perform a signature operation. And once it has enough signatures, it will return the difference between the locked fee and the actual storage price back to the user. So here is what the UI currently looks like. It will prompt you to connect your MetaMask wallet, and it will show all your currently uploaded files using MCS with the option to upload a new file. When you upload a file, it will show you the current estimate in USDC with different lock plans based on the priority of your upload. And once you hit submit, you have to approve the transfer transaction. And after your upload is finished, it will show you the transaction hash as well. And when you click on this transaction hash, it will open the Blockchain Explorer in a new tab. So clicking on one of your files on the UI, it will show you all the file details such as the IPFS download link, the Filecoin retrieval command using Lotus, as well as the DAO signature status. Under the billing history tab, you can see all the payment transactions you've done using MCS, the amount, the network, and such. So moving on to the SDK. It's a toolkit I built. Currently, only JavaScript support. However, the team is working on Python as well. It allows devs to interact with the MCS API. It's lightweight. It's an NPM package with online documentation. So this allows developers to integrate different blockchains, such as, for example, Polygon and Filecoin. It allows them to mint files as NFTs using the simple mint function. And the use cases, there's many reasons to use this. For example, you can write scripts to upload multiple files to MCS at once, mint multiple files, or create your own apps or games. So now I'm just going to show you a quick example of using the JavaScript SDK. In a new empty repository, you just run the npm install JavaScript MCS SDK. You want to make sure that you have a MetaMask wallet with some funds. And you would just make a simple .env file using your private key and an RPC URL. The RPC URL allows you to communicate with the blockchain. Right? For this example, I'm using a free one from Alchemy. The instructions are in the documentation. So you just make a new file, you import the environment variables, and you import the SDK itself. And you set it up passing in the private key and the RPC URLs. And then since you want it to behave asynchronously, you write a command with the async keyword. And here's the first example of uploading a file. We create a simple JSON file that contains our wallet address. And then we create a file array that has the file name and the file contents. And we just use mcs.upload, and it will upload the file. And the response will be the API response from the MCS API. So we run node index, and we get the response. It has the unique source file upload ID, which is just the ID number for the file, the content ID for the IPFS, the IPFS URL, and the size of the file. So now we need to pay for the file coin storage for this file. We replace the main function. We pass in these parameters to the make payment function. All we need is the content ID and the file size and the amount we want to pay. So if we leave the amount blank, it'll do the automatic estimation just like the UI. So if we run this, it'll print out the transaction hash, which we can view on a blockchain explorer. And here, if we want to mint the file as an NFT, all we need is the source file, the unique source file upload ID. We give the NFT a name, an optional description, and it will build the NFT object. And this object is compliant with the OpenSea metadata. So we fill in the IPFS URL and the upload ID, and we just run the simple mint command. And here, this is the response from the mint API from MCS. It has the transaction hash for this mint operation, as well as the contract for the NFT, as well as the contract address for the NFT contract. It also shows you the token ID, so you can see that there's over 100,000 NFTs minted using this already. So here, going back to the UI, following the examples, you see the file that we uploaded, the status is paid, and the mint status is viewable. So clicking this view button, we can see the transaction hash from earlier to see the mint transaction. There's also a link to view your NFT on OpenSea. So if we were to click that, we'd pop up to OpenSea. And if we were to upload an image, then the image would be shown here, but we just uploaded the simple JSON file, which is viewable on the top right. If we click that, it'll send us to the IPFS link. And here this is the IPFS link. It's just the simple file that we uploaded. So if you ever need that information, you can get all your upload information using get uploads. In the documentation, there's a lot of parameters you can pass in to sort the data or filter your data. But for now, we'll just get all the data. And here, running the command, you see the same information from earlier, the upload ID, the IPFS URL, as well as the mint information as well. So that's it for the presentation. For all you devs, happy hacking.